All biotic components are connected through the flow of energy in an ecosystem. These ecosystems are structured by food webs which show how nourishment transfers from trophic level to trophic level and also show the direct and indirect effects species have on each other. Because of the complexity and importance of sound food webs to an ecosystem's biodiversity, removing a single species from a food web could greatly affect the health of the ecosystem or cause a trophic cascade. The species with more disproportionate effects on community-level interactions and diversity compared to its abundance are called keystone species, and when they are removed from an environment, the whole system fails. They pull together the species of a food web through indirect interactions and increase the biodiversity of an ecosystem. This is known as the community effect. The best way to demonstrate this concept is to imagine an arch made up of blocks. In the center of the arch at the very top, there is a block which in architecture is referred to as the keystone. If you remove the keystone block, the whole arch falls to the ground. When you remove a keystone species from the ecosystem, the effect is the same. The coolest keystone species and influencer of the community effect is the wolf. The wolf's effect on the ecosystem is so unique that its version of the community effect is known in environmental science by its own specific name, the wolf effect. In Yellowstone, wolves had been absent from the ecosystem for many years, and because of this, the elk there had grown a robust population. Because there were no wolves to scare away and eat the elk, the population of elk rampaged the park by eating all the riparian vegetation by the rivers. The lack of vegetation over the water meant there was nothing shading the water, which made it harder for the aquatic organisms to survive. It also meant that the songbirds and insects had nowhere to live. Species on all trophic levels of Yellowstone's ecosystem were dying off, until park rangers reintroduced the wolves. When the wolves came back, they simply did what wolves do, eat the elk. But this was enough to scare the elk and force them to avoid the rivers. The behavior of the elk shifted to accommodate the wolves, and this changed everything. The areas that the elk had overgrazed replenished themselves. The vegetation started thriving again, and in turn, the songbirds, insects, and fish populations went back up to normal. Species that had been absent for decades moved back in, like migratory birds and beavers, who built dams that serve as habitat for even more species like otters and ducks. The list goes on and on. The simple reintroduction of a small population of wolves increased so many other species populations. Even more unbelievably, the wolves also had a positive impact on the elk population. The wolves always catch and eat the slowest elk, who are usually the oldest or sickest of the pack. This kept sickness from the slower elk from spreading to the rest of them, and kept the population healthy and growing. So you can see that the wolves have an effect on the entire rest of the ecosystem, like the songbirds, insects, and fish, even though they don't directly interact through feeding. But wolves control the population of elk and in turn protect the vegetation. With more riparian vegetation, the habitats of many other species are protected, and the diversity of the ecosystem is preserved and even amplified. The wolf effect teaches us how we're all connected through direct and indirect actions, and shows us how one species transforms the entire operation of an ecosystem.